Hello, this is Brother Cromer from the Math Department of UAU Idaho, and this is part 3 dealing with inference for one proportion. And lastly, we'll talk about hypothesis testing. Okay, so with hypothesis testing, here are the 5 steps of how to do a hypothesis test. Step 1 is state the null and alternative hypotheses. So how we state the null, we used to state it in terms of mu, which is our population mean. Now we're going to state it in terms of p, which is a population proportion. We'll set it equal to a certain value, whatever that proportion is. And then the alternative hypotheses can either be a two-sided test, like what you see here, p is not equal to a given value, or it can be greater than or less than if it's a one-sided test. Here's the value. Here's the formula for the test statistic, though you can use Excel, which I'll show you in just a moment, which is what we did earlier with confidence intervals with the Excel. But basically, it's taking our sample proportion minus, and it's different symbolism that's used in the online textbook, but this here, P naught represents your null hypothesis. And we divide it by the null hypothesis times 1 minus null hypothesis divided by n, the square root, that we get our test statistic. And then we get our p-value based off the test statistic, and then we can use the applet or we can use Excel to get our p-value. Okay, and then the decision rule, or the rule to determine whether or not we reject the null hypothesis. We reject the null if the p-value is less than alpha. If it's not, then we don't reject. And then we state our conclusions. If we reject the null, we have sufficient evidence to say that, and then we state the alternative hypothesis in English. If we don't reject, we have insufficient evidence to say that, and then we state the alternative hypothesis in English. Okay? So now let's go through an example. In fact, here's a cartoon here of Family Circus. And this is Billy, and he's saying that I'm making sure that less than half these nuts are peanuts. Okay? Sounds like he had a lot of time on his hands. So, however, not only is he like to count peanuts, he's also a great statistician. So Billy, the boy in the cartoon below, wants to do a hypothesis test to determine if less than half the nuts in the can are peanuts using a level of significance of alpha equal to 0.05. He found that out of 977 nuts, 471 were peanuts, so he got a sample proportion of 47.19% or 0.4719. So step 1 is state the null and alternative hypothesis. The null is that you don't see 0.5 anywhere here, but we're looking to see if less than half the nuts are peanuts, so half is 0.5. So that would be our null hypothesis. We always set it equal to a value in our null hypothesis. The alternative is that we're looking to see if p is less than 0.5, as stated in the problem. So step number 2 is calculate the test statistics. Step 3 is get the p-value. And step 4 is, do we reject or not reject the null hypothesis compared to the p-value and the level of significance. Now we can calculate this by hand, where we take our sample proportion 0.4719 minus our null hypothesis of 0.5 divided by, and this is a standard deviation where we take the null hypothesis times 1 minus the null hypothesis, which is up here, divided by 977, which is our sample size. And so this is the formula as you see over here. We get a z-square of negative 1.759. We can get the p-value by going to the applets, and here's an example of this here. In fact, let me expand this a little bit here. Where here is my test statistic of negative 1.759. We're shading to the left because it's a left-sided test, and then after we type in our test statistic plus press enter, we get our p-value up above, which is 0.039. We can get a p-value in this case in the applet because we're dealing with the z distribution here. Now we can either use this, or we can also use Excel too, the Excel tool that your teacher or your TAs can show you where they are, where this tool is. Okay. What we can do now is we can take x is 461 and n is 977 here, and we have a null hypothesis of 0.5. But now our type of test, there's 3 options. It could be greater than, less than, or not equal to. This is a less than, so we'll click on that. And so notice here that here's our test statistic, and here's our p-value. We can get that from there as well. Okay, so our p-value is 0.039. Okay, and so therefore, since the p-value is less than alpha, which is 0.05, we reject the null hypothesis. So therefore, we would have sufficient evidence to say that less than half the nuts are peanuts. Okay, so then one more example. So the ability to taste chemical. I'm not sure how you pronounce this. I'm just going to go with the acronym PTC as hereditary. Some people can taste it while others cannot. The ability to taste PTC is typically assessed using paper test strips. When a PTC test strip is placed on a tongue, it will either taste like regular paper or else have a bitter taste. It is assumed that the true proportion of people who can taste PTC is about 70% of 0.70. A student wants to test to see if it's different using a level of significance of alpha equal to 0.05. She finds in her sample that out of 118 in her sample, 89 can taste PTC. So step one is state the null and alternative hypothesis. So the null is that it is assumed the true proportion is 0.70, so that's what would be the null hypothesis. P is equal to 0.7. The alternative is that we're looking to see if it is different. So it's non-directional, so we're going to do a two-sided test. P is not equal to 0.70. So we can do this by hand, where we could take the 89 divided by 118 and get our sample proportion, minus the null hypothesis and divide it by the standard deviation, where it's the square root of our null hypothesis times 1 minus our null hypothesis divided by our sample size, which is what you see here in this formula. We get a test statistic of 1.286. And then we can go to our applet, like what you see here, type in that test statistic and press enter, shape both sides, and then get our area up here. So we get a p-value of about 1.199. It looks like here you could argue it would be 0.198 depending on how you got here. But what I'm going to do is that I'm going to go to my applet here, and I'm going to take 89, that's the number of people who could taste PTC, divided by the 118 our sample, and our null hypothesis is 0.7, and type of test is less than, greater than, so it's not equal to, so it's a two-sided test. So we get a test statistic of 1.286, p-value of 0.199, that's where I got the 0.199 there, even though it's slightly different than our applet. But it's pretty close. In the end, it gives us our same, it draws the same conclusion. Because if we compare our p-value to our level of significance, our p-value is greater than alpha, so therefore we don't reject the null hypothesis. So we would have insufficient evidence to say that the proportion of people that can taste PTC is different than 0.70 or 70%. One more slide here. Before doing a one proportion hypothesis test, we need to check certain requirements. First, the sample needs to come from a simple random sample. And the requirement for doing a hypothesis test is that n times p. Now, p is the null hypothesis. It's similar to what I have here as p naught. It's the same thing. So n times our null hypothesis, if that's greater than or equal to 10. And also n times 1 minus our null hypothesis, if that is greater than 10. That way we can assume that the distribution of our p hat or our sample proportions is normal. Now, the numerical descriptive statistics is the same as your confidence interval. We have, it's basically our sample proportion is our numerical descriptive statistic, and graphical is either a pie chart or a bar graph, which I showed you in the previous parts of this of these videos in part 2. Okay, but where we can get these to check the requirements, if we go to from the last example, we can check the requirements right here. These formulas up here show us in Excel how we're calculating these, and we find here that both of these numbers are greater than or equal to 10, so that we can assume that the requirement is met. Okay? And that concludes the videos dealing with inference for one proportion. If you have any questions, please speak to your instructor or to one of your teachers.